As part of this lecture, let's go to the details related to overview of database technologies. We'll be covering quite a few important details so that you understand the relevance of database technologies when it comes to application development using programming languages such as Python. First, we'll talk about limitations of using files for data. Already we have seen how files can be used for data, but when it comes to building applications, using the data in files is not appropriate. There are quite a few limitations. We'll talk about those limitations first and then we'll take it further. So let me first paste what we are going to cover. We are going to cover all these aspects. Limitations of using files for data, then overview of databases. We'll also go to the details related to different types of databases. Then we'll talk about overview of RDBMS technologies. Then we'll get into the details related to use cases for RDBMS databases. Then we'll talk about some of the important concepts which you should be familiar about when it comes to RDBMS as a developer. Then we'll get into the details related to relationship between programming languages and databases. That being said, first let's start with limitations of using files for data. Let's assume you run a company. It can be e-commerce platform. You might want to ship the products to the customers and you want to keep track of the order details of each and every customer as part of the file. Let's assume it is nothing but Excel. In Excel, you enter all the information related to the customer and then you will try to process the order. Now, anytime you want to understand the status of the order, you have to go to Excel and you have to go to that particular record and you have to review the details. Even if you have to update, you have to update by going in there. If you have too many customers who are placing orders at the same time, then using Excel by single user is not appropriate. Also, when it comes to manipulating the data, more than manipulating the data, opening the file for write and then updating the file and then saving, primarily opening the file and saving can take significant amount of overhead. That is where it will become very slow. You will not be able to run your application in a reliable manner. What does that mean? You will not be able to use the files such as Excel or even text files to take care of keeping track of whatever is going on with respect to business. It is exponentially high when it comes to overhead. Hence, we typically don't use files directly. That is where the savior comes. The savior is nothing but a database. A database technology will hide the complexity of opening the file, updating the data in the file, and also saving the data in the file. All those things are taken care by database technologies itself. They are built based upon certain science, and all these important activities are taken care in reliable manner. That's why databases became quite popular in early 90s, and databases are disruptive. They have facilitated people to actually build reliable and robust applications. All the applications which are built beyond 90s typically use one or the other database. In some cases, one application might end up using multiple databases too. So database means the container which actually have the data within itself. Internally, it uses files only. On top of files, there is a software. The software will hide the complexity to maintain the data in the files. As developers, we don't need to worry too much about how to take care of saving the data into the files. When we perform certain operations on databases using certain commands, the saving of the data into the files is automatically taken care of. It can be adding new data into the files, updating existing data in the files, or even deleting the data from the files. So databases are nothing but softwares which will facilitate you to make sure you maintain your data in reliable manner. This is how a typical database architecture will be. There will be file storage. On top of file storage, there will be software. Let's say this is the software. Then we have commands on top of this. We should be able to use commands to take care of interacting with the data in the files. Software will abstract away the complexity to interact with the database. So software will be installed on some server and then the software will be integrated with files. We will not be able to see the data in the files directly. Only the database software can see the data in the files directly. This is how it will be. Let me make sure I specify the bidirectional arrow because software and files here will work together. Then at the top level, we'll have commands. What are those commands? Those commands are nothing but insert, update, delete, etc. The users of this database will interact with the database using these commands. These commands will be converted into underlying code which is interpreted by this software, and it will take care of processing the data based on the statement. However, we will not be using these commands directly. There will be an application layer. We'll typically develop an application. The application can be built either by using Java or Python or Node.js or JavaScript. There are frameworks around these programming languages. Using those frameworks, we'll take care of building these statements. So the application layer will actually take care of interacting with the database using these statements. Let's make sure it is documented here. This is nothing but app layer. As developers, we will primarily focus on developing the applications. Between application layer and the database commands, there is something called as ORM. ORM stands for Object Relational Mapping. You don't need to worry too much about it at this juncture, as long as you understand that you will not be issuing insert, update, delete statements directly. Using some frameworks in programming languages, those will be generated automatically depending upon how we code. So developers work here. The actual data will be saved or deleted using these statements. These statements will be generated by the framework itself. These statements will be sent to the database software. The software will compile these statements and then run against the data in the files. This is the overall process of managing the data using database technologies. All these things will happen in milliseconds in most of the scenarios. That being said, now as we have understood details about overview of databases, let's talk about different types of databases. Here I am talking about different types of databases, not different databases. Let me first create heading here. We are going to talk about different types of databases. Let me keep it in bold. Now let me come up with a bigger rectangle. Let me push it to back. Now let me come up with a text box. Here I'll be talking about different types of databases. Let me actually use the table rather than text box. So in this case, I can come up with a table. Here I'll be talking about type. First, I'll be focusing on different types of databases. Then we'll actually talk about what those actual database technologies are. The first type and most popular type is nothing but RDBMS. RDBMS stands for Relational Database Management System. You have to be fairly comfortable with this acronym. So let me specify the text box here. Let me say RDBMS, R for relational, then DB for database, then M for management, then S for system. RDBMS stands for Relational Database Management System. Every software engineer or IT professional should be familiar about RDBMS. Then we have other type of databases too. They are nothing but data warehouse database, then NoSQL database, then we have something called as graph database. Also we have something called as search database. These are different types of databases. Let's look at different technologies in each of these types. I'll be quoting quite a few popular technologies. When it comes to RDBMS, the most popular one is nothing but Oracle. Oracle is the most popular RDBMS, followed by Microsoft SQL Server. It is also known as MS SQL Server or even SQL. In some cases, they just use SQL for Microsoft SQL Server. On top of these two, IBM have something called as DB2. All these are examples for proprietary database technologies. We also have open source technologies such as Postgres, MySQL, etc. Like these, there are quite a few other database technologies as well. Then comes data warehouse technologies. We have both cloud-based data warehouse technologies or conventional data warehouse technologies. The most popular one used to be Teradata. But as of today, Teradata is not the most popular. We have other data warehouse technologies such as Snowflake, Databricks. Then we have AWS Redshift, Azure Synapse, GCP, BigQuery. Like this, there are quite a few other database technologies as well, which are considered as data warehouses. So far we have gone through the details related to both RDBMS database technologies as well as data warehouse database technologies. Then comes NoSQL. When it comes to NoSQL, we have hundreds of them. The most popular ones are nothing but MongoDB, then Cassandra, then Amazon DynamoDB. When it comes to Azure, we have Cosmos DB. Under Cosmos DB, we have quite a few of them. When it comes to GCP, we have something called as Bigtable. So Cosmos DB is from Azure. Bigtable is from GCP. Like this, there are quite a few NoSQL database technologies. When it comes to graph, the most popular one is nothing but Elasticsearch and Solr are examples for such. Let me specify those things here. Elasticsearch, Solr, etc. For graph, we have something called as Neo4j. Neo4j is graph-based database based on my limited knowledge. I might be wrong. So like this, there are different types of databases and these are the technologies. As part of our course, we'll explore Postgres, which comes under RDBMS, and also we'll explore MongoDB, which comes under NoSQL. These two are the database technologies which we are going to explore as part of the course. First, we'll talk about Postgres, then we'll get into the details about MongoDB. Now, let's understand what type of use cases are implemented against each of these type of database technologies. So when it comes to a business, you need to transact with your customers. Your customers will pay money and try to purchase the product. You are supposed to fulfill the order by shipping the product to them and ensuring the product is shipped to them without any issues. If the customer wants to cancel, he have to return the product to you. Once you receive the product, you take care of the refund and then the transaction might be closed. These are nothing but transactions between you and the customer. For transaction-based scenarios such as purchasing a product and shipping the product, etc., we use RDBMS technologies. Now, as a owner of the company, you might want to see how your business is performing. You might want to see what products are sold frequently and what products are not sold. What is the performance of the products over a period of time? If it is a big e-commerce platform, it can be category of products also. You might want to see which categories are performing well and which categories are not performing well. You also might want to see the performance of your team members within your sales department and all. For those, you need to analyze the data over a period of time and see reports and dashboards. To take care of those kind of scenarios, we use data warehouse database technologies. RDBMS is used for transactional based use cases. When it comes to data warehouse, it is used for analytical use cases. So let me actually add one more column here. Let me say use cases. Here we'll be using for transactional. These are also known as OLTP. OLTP stands for online transaction processing. It is very important for you to understand this term if you wanted to become a web or mobile application developer. Then comes analytical applications. These are called as OLAP. OLAP stands for Online Analytical Processing or Analytic Processing. Data warehouses are typically used for OLAP based applications. These are also known as DSS. DSS stands for Decision Support System. By looking at the details about how the product is performing, you might want to decide whether to continue that product or not. So data warehouse is supporting your decisions. That's why these are called as Decision Support Systems. For OLAP, DSS, we use data warehouse based databases. Examples are nothing but Teradata, Snowflake, Databricks, AWS Redshift, Azure Synapse, GCP BigQuery, etc. Then comes NoSQL. If you are running a e-commerce platform, you might have hundreds and thousands of products you wanted to sell. You might have to take the images of the products. You might have to enter the description related to the products. You might want to maintain the price related to the products. You might want to capture the feedback around the products, so on and so forth. You don't need to implement the product catalog or the system which actually take care of onboarding or offboarding your products using RDBMS databases. You can use NoSQL databases for those kind of scenarios. It will be easier for you to scale up using NoSQL databases to maintain your product catalogs and also your recommendation systems, endorsement engines, feedback systems, so on and so forth. So NoSQL is widely used in non-transactional real-time scenarios such as maintaining your product catalog related to your e-commerce platform, maintaining the feedback from the customers, so on and so forth. So recommendation systems is one of the popular use case when it comes to using NoSQL. On top of these things, we can even consider NoSQL for product catalog, chatbots, etc. Then comes graph. When it comes to social networking platforms such as Facebook, LinkedIn, etc., there will be network based on user, based on movie, based on quite a few other criteria. So those are actually built using graph-based databases such as Neo4j. So in case if you wanted to build a social networking platform, you might have to use Neo4j type of databases to maintain the data so that the graphs are quickly built. Many times you want to go to certain website and you might want to search for a product based upon certain criteria. For example, if yourself are running a e-commerce platform where there are hundreds and thousands of products related to different categories, the user might come into the search bar and search for 53-inch TV or 53-inch television or the 3D glasses for Samsung TV or pair of clothes for a kid. Like that, the user might enter information for free flow search. In those scenarios, if you try to build the search engines using RDBMS databases, it can be overkill. Search based databases will streamline the process and you will get search results, or your customers will get search results much faster. We typically use technologies such as Elasticsearch, Solr, etc. for free flow such type of use cases. So this is how you can actually visualize the details about different types of databases, the technologies that are relevant to these different types of databases, and also the use cases. Yeah, we have covered quite a few important aspects with respect to different types of databases. Now let's talk about overview of RDBMS technologies. Already I have covered quite a few important details. Once again, I'll reiterate only the details related to RDBMS because our immediate focus as beginners with respect to software engineering should be RDBMS. Then we can add additional technologies. When it comes to RDBMS, it stands for Relational Database Management System, R for relational, DB for database, M for management, S for system. These are the popular technologies with respect to RDBMS. Oracle is the most popular one. Then we have Microsoft SQL Server. It is also known as SQL Server or MS SQL Server or just MS SQL. Sometimes people refer it to as just SQL. All actually mean MS SQL Server only. Then IBM have DB2. Then we have very popular open source RDBMS, which is nothing but Postgres. MySQL used to be popular, but it is acquired by Oracle. Once MySQL is acquired by Oracle, people started embracing Postgres over MySQL. That's why Postgres is the most popular choice when it comes to open source RDBMS technologies. When it comes to use cases, we use RDBMS databases primarily for transactional use cases. These applications, which are transactional in nature, are also known as OLTP applications. OLTP stands for Online Transaction Processing. Let me make sure I keep it in bold. Online Transaction Processing. OL stands for online, T for transaction, P for processing. Now let's get into the details related to use cases. Already I have covered use cases, hence I'm moving on to important concepts within RDBMS for developers. These are the concepts which you should be familiar about to begin with. We'll be covering some of the key concepts as we set up Postgres and practice how to set up tables in Postgres and also get data into the tables. Then we'll actually get into the programming aspects of it. First, let's focus on the important concepts which we are going to cover at beginner level. So let me copy this. Now let me actually come up with another big rectangle here. In this, let me come up with a text box. Let me paste it. Here we are going to talk about important concepts within RDBMS for developers. Now let me create one more text box here. First and foremost, you should be familiar about tables. We create tables in RDBMS databases as developers. Then you should be familiar about records. Tables contains records. Then you should be familiar about indexes. Indexes are primarily used to get the data from the tables at a faster pace depending upon certain important criteria. On top of these things, you also should be familiar about something called as CRUD operations. CRUD operations are nothing but create, read, update, and delete. C for create, R for read, U for update, D for delete. These will translate into commands in a database. The commands are nothing but insert for create, select for read, update for update, delete, delete for delete. So for insert we use C, for select we use R, for update we use U, for delete we use D. CRUD is more popular when it comes to applications. When it comes to databases, we use these statements. These statements are known as DML statements. So let me say DML statements. DML stands for data manipulation language. All these commands fall under something called as SQL. As a developer, you should be fairly comfortable about SQL. SQL stands for Structured Query Language. We have different categories of statements within SQL. We'll talk about those categories very soon. On top of SQL, you also should be familiar about how to take care of interacting with databases by developing relevant programs. That is called as database programming. As the engineer, you should be familiar about database programming, where you build applications interacting with the databases. That being said, now let's come up with another table here. So this table will have details with respect to 3 different categories of statements and also examples. Here we'll be specifying the category, then description or full form, then examples. When it comes to categories, we have 3 of them. They are nothing but DDL, then DML, then DQL. When it comes to DDL, it stands for Data Definition Language. When it comes to DML, it stands for Data Manipulation Language. It is very important for you to understand these abbreviations and acronyms. Finally, DQL stands for Data Query Language. Examples for DDL are nothing but create table, drop table, alter table, create index, and then etc. There are quite a few commands when it comes to DDL. Even though there are many commands, as developers we will not be using these commands very often. Only once or twice we will be creating the tables, and then we will be using these tables over a period of time. However, as an engineer, you should be comfortable with most of the important commands which you can use to create tables, drop tables, create index, drop index, so on and so forth. When it comes to data manipulation language, we have only 3 main commands. They are nothing but insert, update, delete. On top of these things, we also have one more, which is nothing but merge. Merge is nothing but combination of insert and update. At a beginner level, it is important for you to be familiar about these 3 commands. Insert, update, delete. Merge might not be that important to begin with. It is a bit advanced in nature. When it comes to data query language, we typically use select. But as part of select, there are quite a few other clauses. You should be familiar about all those clauses. The clauses are nothing but from clause, where clause, group by clause, having clause, order by clause, etc. At a beginner level, we don't need to get into all those nuances with respect to select statements. Select statements fall under DQL. As engineers, we spend a lot of time in writing select queries. We rarely write insert, update, delete, merge directly. We might write those through programming languages or frameworks. Once in a while, we take care of creating the tables, dropping the tables, etc. based on the requirements. In general, you should be familiar about all these 3 categories of statements, but we use select more often compared to others. As we have gone through quite a few important details with respect to database technologies and also RDBMS in general, as part of subsequent lectures, we will see how to set up Postgres database, and also we will make sure we create tables in Postgres database. Then we will talk about CRUD operations using SQL, which means we will be exploring DML statements such as insert, update, delete. We use very simple statements. We will not be getting into too complex statements at this juncture. Once we go to the details related to CRUD operations using SQL, then we will actually talk about database connectivity using Python. Then we'll get into the details related to overview of database programming using Python. We'll also go to the details about loading CSV data from files to database tables, so that you understand how we take care of database programming using programming languages such as Python. That being said, now let's conclude this lecture with relationship between programming languages and databases. As I have mentioned to you earlier, databases are the ones where data will be permanently stored. It is called as persisting the data. Persist means permanently storing the data. We don't interact with databases directly. We build applications using programming languages to interact with data in the databases. As engineers or programmers, we have to be fairly comfortable with respect to building applications pointed to databases. We'll explore those details as part of subsequent lectures in this course. Before moving on to the next lecture, make sure you watch this lecture multiple times and understand all the keywords that are specified. You should be familiar about different types of databases such as RDBMS, data warehouse, NoSQL, graph, search, etc. Which database fall under which category, and also what are the use cases when it comes to these different types of databases. On top of these things, you should also be familiar about the important concepts within RDBMS for developers such as tables, records, indexes, CRUD operations, SQL, database programming, etc. SQL is categorized into three. They are nothing but DDL, DML, and DQL. DDL stands for Data Definition Language. The examples are nothing but these. We'll soon use these statements to create tables in the databases which we are going to create using Postgres. DML stands for Data Manipulation Language. Once the tables are created, to get data into the tables, we use these statements. We'll cover insert, update, and delete up to an extent. Then DQL stands for Data Query Language. In case if you want to read the data from the tables, we use select statements which fall under DQL category. You should be familiar about all these terms before moving on to the next lecture. Make sure you take this one seriously, even though it is theoretical in nature. Watch the lecture 3-4 times and also watch multiple times over a period of time so that all these terms get into your mind without much confusion. Don't worry too much if there are gaps at this juncture. We'll be hearing these terms quite a lot as we move forward. Once you see some things in action, you might be able to digest some of the information even though they are not clear at this juncture. I would highly recommend you to watch this lecture multiple times before the end of the course so that you remember all the key terms that are covered as part of this lecture.